So this is the 2014 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 4. Part A says solve the equation x squared minus x minus 6 equals 0. Okay, so this is a quadratic equation. So we're going to use the quadratic formula, which I've taken from the tables book here. So if you remember, x squared is the same as 1x squared. Minus x is the same as minus 1x. Minus 6 equals 0. So then we can establish our a, b, and c values. Remember, a is the coefficient of x squared. So our a value is 1. B will be the coefficient of x, which is negative 1. And c then will be the constant term, which is minus 6. So we're just going to sub those values into this equation. Do it once with plus on our calculator and once with minus. So what we get is x is equal to minus b, which is minus 1. Just be careful there, that minus is apart from the b value, which happens to be negative as well. So minus 1. Each letter that you substitute in a value for, you should protect with a bracket. So we have plus or minus a bracket squared minus 4 by a bracket all over twice a bracket. Good habit to just replace all the letters with brackets, and now you can put them in. So b in here was minus 1 again, a was 1, c is minus 6, and a down here again is 1. So now you do this once with plus on your calculator. So you use the plus, put a plus in here on your calculator, ignore the negative. When you put a plus in, all this in your calculator, you get an answer of 3. And when you put in a value of, or a negative sign there, you get a value of minus 2. So with negative you get minus 2, with positive you get 3. So there are the two answers. That's the solution to the quadratic equation. Part B says the graphs of 4 quadratic functions are shown below. So we've got graph A, graph B, graph C, and D. The question says which of the graphs above is that of the function f of x mapping onto x squared minus x minus 6, where x is an element of the set of real numbers. Okay, so we should recognize that this function here is actually the equation that we just solved, x squared minus x minus 6. So we just looked at where that function was equal to 0. And the answer we got was 3 and negative 2. So we know that if this was a function, it would be 0 at 3 and negative 2. So we can see then which graphs here have 3 and negative 2 as the x-intercepts. Well, it's not this, it's not graph A, because that intercepts at 2 and negative 3, as does graph B, so it's not graph B either. And graph C and D, they both cross at 3 and minus 2. 3 and minus 2, which were the answers we got, 3 and minus 2. So the question is, which one of these graphs is it? Is it C or D? Well, one graph is what we call a cup graph. They're both parabolas, but one is a cup parabola and the other one's a cap parabola. So the way we decide which is the correct one is whatever number is in front of the x squared. If that number is positive, then it's a cap. So if you've got a graph like that, we'll have a positive coefficient of x squared. If it's cap like this, it will be a negative. So we know that ours is positive. It's just x squared, which is 1x squared. So that's positive 1x squared. So it's going to be the cup graph. So the cup one is graph D. Graph D is the cup graph with intercepts, x-intercepts 3 and negative 2. So the answer is graph D. Okay. Finally, part C. The graph of g of x equals x squared minus 2x, where x is an element of the real set of numbers, is shown on the diagram below. So here we have the graph of g of x. On the same diagram, sketch the graph of each of the functions. One, h of x, which is equal to g of x plus 2. And number 2, k of x, which is equal to g of x plus 2, all in brackets. Label each sketch clearly. Okay, so this is graph transformations. So you can just put 2 onto the end of this and then do a table out and plot the points and so on. And you can do the same here, replace the x and the x here with x plus 2, multiply it all out, do a table, even using the table function on your calculator. But there's a shortcut to doing these that you should know. If we just add on a constant at the end of the function, what that does is it just shifts the function up the y-axis by that much, or down if it's negative. So because you're adding 2 on here, I have positive 2 at the end, that just means you're shifting the whole function, or the graph of the function, up 2 units along the y-axis. In other words, the bottom here would go up to 2 units, up 1, 2. This bit would go up 2. This point here, up 2. This point here, up 2. 1, 2. And the same over this side, so this would go 2 units, up 2, and up 2. So you would just try and smoothly then draw this, which isn't easy to do with this. As smoothly as you can anyway. You draw a parabola like so. You can draw a smoother line than I can with this, but it's shifted 2 units up like so. So that's going to be our h of x. So that's h of x. And then the other one, which is k of x, is equal to g of x plus 2. This time the plus 2 is inside the bracket, so it's the g of x plus 2. So when the constant is put inside the bracket, that means it's a shift along the x-axis. However, it's opposite to what the sign is. So if the sign is plus 2, or if the constant's plus 2, the shift will be negative to the left 2 units. If it was negative, it would be to the right. So that means from the original function, we're going to shift it 2 units to the left. So we're going to shift this, I'm going to do this in a different color, 2 units to the left. So over, that will be the bottom. This one here would go there. This would shift 2 to the left to here. This one would go to 1. And this one here would go well, we can just do the last one here. 4 would go to 2. So the same then over here, that's shifted 2 to the left. This one here would go to 3. And this one here would go to -4, which would be there. So again, drawing as smoothly as you can. You can draw this smoother again, but a parabola shifted to the left twice, and that one's going to be your k of x. So that's the 2 graphs transformed, and that's the end of question 4.